Hello
Recording in
and
progress.
welcome to Full Tech Ahead. I am your host, Amanda Razzani, and with me today I'm here with Eran Ofir. He is the CEO of Imagry. How are you doing?
Hi, I'm good. I'm very good. Thank you, Amanda. Great seeing you.
Well, I'm excited to speak with you today about autonomous vehicles. But first, if you can share a little bit about Imagry and yourself and your background.
Thank you. So at Imagry, we do generative autonomy, which means we do autonomous driving for physical AI, meaning we make machines move on the road. It could be passenger vehicles, it could be buses, but we make them work with autonomous driving. So we are a software company, AI based. Our software is doing perception, motion planning, and control, which are the three components that are needed in order to make a vehicle move autonomously. So that's about imagery. Myself, I've been with Imagery since 2021. The company started working on autonomous driving in 2018. Prior to Imagery, I had few other businesses that were acquired by Huawei, NEC, and NCR in different domains, telecom, retail, utilities, and so on. But they were all B2B software businesses.
Wonderful. Well, let's get right into it. The autonomous vehicle industry is developing quite quickly these days, and I would love to hear more about you've talked about generative autonomy, and I'd love to hear more about that and what makes generative autonomy different than, say, the regular traditional autonomous driving approaches.
All right. So before even talking about, generative autonomy versus other types of autonomous driving engines, let's remember that autonomous driving in general is considered, and rightfully so, the most complicated, the most advanced form of AI currently. Because, first of all, it's in the physical world, it's not within your laptop, and it's not generating, text or video or near time AI. Not only that it's a real time application, but it's a critical mission application because your life depends on it. The latency of the autonomous driving vehicle that you are in will determine whether your success in on that journey. So that's something which is very different, and this is why the quality of how we train the neural networks and the quality of the software with respect to the rigorous testing that we need to do is much higher even than the regular typical automotive standards, right? So it's really kind of pushing to the very edge. Now, when you compare between different types of autonomous driving, so once upon a time, the companies that were doing autonomous driving were doing rule-based coding, meaning they wrote a code like we used to write codes 15 years ago, where everything was like decision trees. If this, do that, and so on, and they were trying to predict all possible scenarios that could happen on the road, and what should the vehicle do then. Um, and they can create all these mapping of situations and scenarios and sub scenarios and so on. And it could never work because, first of all, you cannot map all the scenarios that could happen on the road. That's one thing. And the other thing is that when you're trying to develop such a software, the latency time, meaning the time to respond and go through that computing process, is simply too long and too dangerous. So every company that went down that path was either shut down, and there were so many of them, All those companies were shut down or they reached a kind of a glass ceiling, and that's it. And they needed to change. Imagery started from the get-go of building, even before it was known as AI, building in 2018 a system that was all based on AI. And it was, in fact, founded by people who came from brain sciences, because the notion, the philosophy beyond the imagery software is that it really needs to work as a human being, as us, in terms of seeing, understanding, and acting. So the perception layer is indeed what interpreting everything that is happening around the vehicle, 360 degrees, 300 meters. And then there is the motion planning, which is kind of like our cortex, which makes the decisions, and that's how the car, deciding what to do. And eventually there is the control, which is like our hands, basically, or the nerves that sends commands to our hands and our legs and everything that we move in order to activate or to control the actuators. So when you do that, it's a very long process because of two reasons. First of all, you need to train for many years, and we've done that since 2018. Many different neural networks that were trained to do object detection and classification and make decisions. And I'm talking about training them with hundreds of millions of images in order to get to them to that level. And the second thing, which was complicated, and that was kind of the major dependency of autonomous driving and why it really didn't happen for no one until kind of 2 years ago, is because of the computing. Because I think that only like 3 or 4 years ago, people in the industry, we all remember like Elon Musk at Tesla that talked about, I don't know, 10 years ago, that they will do like autonomous driving coast to coast in the US. And it wasn't doable because the computing that is needed, the edge computing, right, in the vehicle, in terms of TOPS, tera operations per second, is much more than what was available then. And only about 2 years ago, companies, silicon companies, NVIDIA, Qualcomm, Tesla, with their own chips, reached to that level that they introduced computing which was sufficient in its volume and speed to be installed in a vehicle and that could serve the autonomous, the neural networks, the AI-based machines that are needed in order to, and it's not a coincidence that you see Waymo and Tesla and other companies flourish in the last 2 years, suddenly with hundreds or thousands of autonomous driving vehicles on the road. It happened because suddenly the hardware, because it's integrated, right? It's embedded, software and hardware, got to the stage that it's strong enough in order to run the models that are needed. So that's kind of the very long answer to your simple question.
No, thank you. But that was very informative and interesting. And so the software that y'all have produced, I believe it's called Cortex. Is that correct?
Yes, right.
Okay. And so it's
That's
training with HD maps, LiDAR,
no, no,
cloud.
no, no. So that's exactly the point. So that's exactly our advantage. Our advantage at Imagery is that we really went all in. If we, trying to build something that will act like a human, so that's what we do. So we don't have HD maps, as we don't drive with HD maps. We create them on the go, on the fly, as we drive, like you and me. The system sees everything around, and there are many small neural networks that each neural network was trained on a different type of object. So one was trained on the traffic lights, and one on traffic signs, and one on pedestrians, and one on lanes, and circles, and so on. Many parked vehicles, moving vehicles, motorcycles, and stuff like that. And we collect the output of all those neural networks in real time. We place them one on top of the others. And that way we create, it's the same process that is happening in our brain. And that way we create an image of everything that we see, including the understanding, right? So that's how we do the perception. And then, and we do all of that with cameras only, because we humans, we don't have LiDAR and we don't have radar. We have eyes. And the advantage of cameras is that, well, first of all, they are it's not a fusion processing, so you don't need to have excessive hardware in order to do fusion of cameras and lidars and radars. It's you can do it all with cameras, and also something which is super important. Cameras understand what they see. If you're a LiDAR or a radar, you do not understand that, a traffic light or a traffic sign, you cannot read a traffic sign. You cannot read colors in a traffic light and so on, because it doesn't work like that. But cameras do. And that's the advantages of cameras, because there is no half pregnancy or halfway. If you decided that you build a system that is AI based, that is walking and is driving like a human being, then it needs to go all the way.
Great. Thank you for clarifying. So it's not even using that technology. It's gone beyond all that.
Yeah, there are only three companies in the world that work in that way, where basically it's based on vision only, and without maps. It's basically Tesla and Imagry and Xpeng, which is a Chinese company that is manufacturing vehicles like Tesla.
Great. So you've already deployed this technology across quite a few fleet vehicles. What has been the outcome? What real world lessons have you learned as you deploy this technology?
So we started with deploying it. Further, Imagery has been driving autonomously on public roads since 2019 in the US, Arizona, California, Nevada, and Germany, and Japan, and Israel. And until a year ago or 6 months ago, we were the only company in the world, autonomous driving company in the world, that was driving on both sides of the road, like Germany and US, where you drive, on one side, and Japan, where you drive on the other side. But we started with passenger vehicles, but then in 2023, we discovered a big blue ocean where there is a dire need for autonomous buses, because there is a global shortage of 20% in bus drivers, and it grows by 1% every year. And there are places like Japan, for example, where in the next decade, 40% of bus drivers are going to retire. That's a very big problem. Now, the situation is that public transportation operators globally do not manage to meet the demand in cities because they don't have drivers. And if you take into account urbanization or the growth of cities and aging, it's a problem that is only getting worse. So governments are promoting, governments, municipalities, public transportation operators, everyone are pushing towards a gradual migration towards autonomous buses. Because then they can operate, buses almost 24/7 and send more buses on the road during peak hours, which is very profitable for them because bus operators are being paid by mileage. And because they are being paid by mileage, when they send more buses on the road, they make more money, and they don't have the cost because then they don't need to employ drivers. So we discovered that the sector in 2023, and we became the world leader in that sector. We are working with public transportation operators in Japan and Germany and Hungary and Israel and Portugal, and now getting also into the US. So that became a very dominant sector for us. We integrated to date with five different bus manufacturers, so that we have buses that are homologated, meaning they can go on public roads, both in Europe, Japan, and the US, which is very because typically companies work either in Europe or Japan, and we worked with different bus manufacturers in order to work in all regions. And on top of it, as a new twist, last month we signed in November 2025, we signed our first Robo Shuttle contract in Europe, where we are to deliver 50 driverless level 4 Robo shuttles in Riga, Latvia. So that's a new direction that the company now is getting to, enabling Robo shuttles, basically. We have three very clear advantages there. The first one is our technology enable us to do HD mapless, right? So we don't need pre-prepared maps, which means that unlike many robotaxi services today, it's not only that we can drive only in very limited geofenced areas. We can drive everywhere because, again, we don't need a map. So that's one. The second thing is a very important commercial benefit because we are white label. Unlike, for example, Waymo or Uber, we don't care what's written on the vehicle. For us, it could be any fleet that to which we provide pre-integrated autonomous driving robo shuttles. And the third thing, which is very meaningful, is that unlike, for example, Waymo vehicles that their cost, is over $200,000 per vehicle, because of our technology, the unit economics in our case is something like $70,000. So a third of the existing cost of robo shuttles, which means that the return on investments to fleets is going to be a third. I mean, it's going to be much faster, basically, than with other solutions. So now we are also getting into fleets in Europe at this stage with robo shuttles.
Wow, that is very significant cost reduction. So this is public transportation. Can you speak to, do you have any stats on safety so far? And then since you are globally located, how much of a challenge is it to adhere to all the different regulations and laws and
Yeah.
standards?
Right. So regulation is right for you. You rightfully mentioned regulation as the big topic here. That's the elephant in the room. In this domain, regulation is currently the main factor that is pacing the industry. We work together with regulators in Europe, in Japan, in order to advance gradually towards having, again, level 4, meaning driverless vehicles on the road. It's every country which is with its own regulation. It's never the same, meaning even though there is like a European framework, still each country like France, Japan, Netherlands, Portugal, and so on, they took, Germany, I meant, they took their own direction. So that's one big thing that we need to look at. Now, in terms of when you do these deployments, it's not immediately. Typically, it takes something like up to 18 months to get to a stage where you can get the permit from the local Ministry of Transportation or DMV in the US to drive autonomously on public roads. And obviously, as you mentioned, indeed, it has a lot to do with safety. So first of all, we need to bring, for example, a bus that is homologated to drive on a public road in a country. Then we need to pass all local safety protocols in that country. Then we need in some countries to pass NCAP testing, which is a very rigorous, and we are the first and only company in the world that passed that test with autonomous buses, which means 90 different scenarios where the bus drives between 30 to 60 kilometer per hours, and it needs to do emergency stops with all kinds of things that are jumping before in front of the bus on the road. And by the way, passing score is 100. You cannot fail even once. And only after you pass that test, you can drive autonomously with a bus with an M3 category, meaning a full-size bus on a public road. And even then, you are not allowed to onboard passengers. In order to onboard passengers, you need to pass a cyber testing. There is the UNR 155 cyber framework in Europe that is mandatory since August 2024. And we were the first to pass that test. And only after you pass the test, you can onboard passengers to an autonomous bus that drives on a public road, unlike an operational zone. And then in order to pull out the driver and continue without the driver, which is the end goal, obviously, and where the operators are making the money, the benefit of it. In some countries, we need to drive, for example, 100,000 autonomous kilometers with those buses on that road, with that model of a bus. And then we submit the results, that implies obviously about the safety of that to the local Ministry of Transportation. And then they give us the permit to pull out the driver and to drive driverless. So it's a very long and rigorous process, which very few companies in the world can do. Currently, only 3 companies in the world are capable of even, going through that entire process. So yeah, it has to do a lot with regulation, and even more than that with safety. And you asked something about safety, and I think that it is important to explain because everyone are talking about that. At the end of the day, it's the public acceptance, right, that will determine how fast this industry will evolve. So autonomous vehicles, for example, our vehicles, the fastest driver on Earth, like a Formula One driver, his response time to events that are happening on the road, with everything is like 330 milliseconds. And it obviously for regular drivers is 500, 600 milliseconds and so on. Our system responds to events that are happening on the road 360 degrees, 300 meters. I cannot drive knowing what's behind me. In sub 100 milliseconds.
Wow.
So our vehicle is at least 3 times faster and safer than a trained human driver. So
Wow.
that's and on top of it, in late meaning we can see first large scale reports that are coming out in the US from NHTSA about Tesla and from Waymo, and you can see that in all cases it is proven that if humans were to drive the same mileage that was driven by autonomous vehicles, then the number of accidents that would occur with human drivers would be 2 or 3 orders, in terms of orders of magnitude higher than the autonomous vehicles. So now even the statistics is there from companies that are, operating many, like large volume, high volume of autonomous vehicles to demonstrate that autonomous vehicles are safer than human drivers.
Absolutely. Well, how long in your mind will it take for the world to embrace autonomous vehicles? And how long do you think it'll be before it's all autonomous vehicles on the road?
Wow, that this will take time because first of all, the regulation until it will really be allowed. Second, with the OEMs, um, between what we call design win, between the decision to implement something like that, all the way to the vehicle being on the road with the needed hardware and software and so on, it's typically something like 4 years. That's a cycle in automotive. So and you can see now that most OEMs, still meaning they have ADAS, but they don't really have autonomous driving level three. It's only Tesla and some very high-end models of Mercedes and BMW, and maybe some Chinese companies, car manufacturers like XPeng. That's it. And not to speak about level four, right? Without driver at all. That's no one even on passenger vehicle is working on that currently. This will probably it will take, I would say, a decade until we'll see mass volumes of consumer regular everyday vehicles that will get on the road with those capabilities. And then there is that public acceptance that we need to take into account. When assuming that technology is there, OEM car manufacturer cycles is there, regulation is there, then there is the public acceptance. And this probably will take, I would give it a decade, because even for buses that are safer, I know that it's like counterintuitive, but autonomous buses are safer than autonomous passenger vehicles, because autonomous bus, when you think about it, it drives in a fixed route, right? The same line number 5 in a city is 18 stops along 9 kilometers. So it's learning in terms of AI learning really quickly the that road, that environment, and so on. And autonomous buses, because they drive in a city, they are all also limited to speed. 40 kilometer per hour, 50 kilometer per hour, and so on. So they drive slower than regular vehicles. So even with autonomous buses, we see cases in which some people are afraid or concerned or hesitate to onboard those buses. So we know that it will take time to educate the public.
All right. Well, thank you so much for coming on the show and sharing your insights into this interesting industry.
Thank you. Thank you. It has been a pleasure. Thank you for inviting me.
And thank you to our audience. If you have any questions, share those in the comments and then comment what was the most interesting to you. Where do you see the future of autonomous vehicles? All right. And until next time, have a wonderful week.
Thank you. Happy New
Thank you.
Year.